this video lesson is all about the idea of multiplying decimals. To follow up on the video lesson we had on adding and subtracting decimals and go through the full set of decimal operations. So first I want to take a minute to look back and review what it means to multiply integers, how we go through that very, very briefly, and specifically how that relates to the multiplying of decimals. So first, if we have an integer idea here, 34 times 26, we start with whatever our ones digit is. And we multiplied just this 6 by 34, 6 times 4, starting with the ones column is 24, carry the 2 up. 3 times 6 is 18, plus 2 is 20. This is not going to be a review of how to multiply integers, but we will go through it step by step here. Moving then on to the 2, which is actually represents a 20, we have to put the 0 at the end to make sure we've got that. 2 times 4 is 8, and 2 times 3 is 6. So we have 884 as our product for 34 times 26. So that is just a very brief review of how we multiply integers, the processes that we use, etc. But now I want to look at a slightly different problem that involves a decimal point, 34 times 2 and 6 tenths, or in short phrasing, 34 times 2.6. And the big question here is, what's the difference? Well, the numbers are not different, of course, but as you immediately noticed from the problem, the big difference now is that we have a decimal point. 2.6 is a little bit less than 3. So we would expect that 34 times 2 and 6 tenths, which is less than 3, would be somewhere in the vicinity of 100, but probably less than 100. If we were using estimation, where we had 34 times 3 is 102. So we would expect 34 times 2 and 6 tenths to be less than 100. But if we wanted to figure out exactly what it is, we have to do something with that decimal point. And so what I want to look at first is, how does 34 compare, or rather not 34, how does 2 and 6 tenths compare to 26? So take a second, pause the video if you like, and try to figure out a very specific, directed way that 26 and 2 and 6 tenths relate to each other. Well, if we start with the 2 and 6 tenths, and we want to make our way to 26, I'll rewrite the 26 over here on the right-hand side. If we start with the 2 and 6 tenths, and we have the decimal point there, and we have the same digits, we just need a different place value. So if we multiply 2 and 6 tenths by 10, we end up with 26. And in that case, we can see how 2 and 6 tenths and 26 are related. But I want to look at the other direction. If 2 and 6 tenths times 10 is 26, that means that 26 divided by 10 is 2 and 6 tenths. And so that is the big comparison that I want to start by looking at here, and hopefully that will give us a way that we can look at multiplying decimals there. And so, how does this affect the product of the problem? We know what 34 times 26 is. We want to know what 34 times 2 and 6 tenths is. So let's look at that again. 34 times 26, I won't go through the whole process here, but I will just rewrite all of this here so we can see how it works. 884. And now what about 34 times 2 and 6 tenths? Well, we know that 26 divided by 10 is 2 and 6 tenths. And so if we're multiplying that same thing by 4, it makes sense, it should intuitively make sense, that if we take one number, one factor, and divide it by 10, we should just be able to take our product and also divide it by 10 and get 88 and 4 tenths. We'll take a look at exactly how that works when we get to talk about it in class. But let's take a look at the process for multiplying decimals and see how that works. First, just like in integer multiplication, we don't bother lining up a decimal point. In this case, in integers, the ones end up lined up. We just don't bother with it here because we're multiplying, we're not adding. So we don't need to line up the place values. So we start there. Then we remember that 34 times 26, and 34 times 2 and 6 tenths are related in that 26 divided by 10 is 2 and 6 tenths. So we thought that maybe our product divided by 10 would give us what we needed because we have one number here. Just one of our products is divided by 10. And because multiplication and division are related, maybe this is how it starts. And actually, that is how it starts. So let's go through the process. We actually just multiply through the digits of our decimal multiplication, ignoring that the decimal point is there to begin with. If we take 34 times 26, we have 204, 680 as our partial products, and then end up with 884. But now we've got this decimal point that we have to worry about. So we've taken 26, and we've divided it by 10. So I'm going to rewrite that for a second here on the left. 34 times 26 divided by 10, which 2 and 6 tenths is just 26 divided by 10. So that means, because multiplication is commutative, and because we're actually going to take away these parentheses, it turns out that if we rewrite it like this, it actually gives us the exact same product as this one does up here. 34 times 26 divided by 10, and 34 times 26 divided by 10. And so we look at our decimal point, and we're interested in the same number of decimal places as they are above, because this is taken 26 divided by 10. It has one decimal place. And so we just carry all of those divided by 10s and all of those decimal places down to the final product. So let's take a look at that for just a second. An example that is a little bit more complicated, not terribly complicated, but does involve just a few more decimal points. We'll start with obviously the 5 in the 2 and 5 tenths. Again, I'm not going to go through a step-by-step process for how to multiply two multi-digit numbers together, but I will take you through each digit. 5 times 4 is 20, times 2, 5 times 2 is 12, or 5 times 2 is 10, plus 2 is 12, one more, 5 times 1 is 5, plus 1 is 6. Add our 0 because we're moving to the 2. 2 times 4 is 8, 2 times 2 is 4, and 2 times 1 is 2. This gives us 0, 0, 1, 3. So we have 3,100 at the bottom. But now we're looking at that. That 3,100 is actually our product for 124 times 25. Now we've taken 124 and we've divided it by 10 to get to 12.4. And we've taken 25 and we've divided it by 10 to get to 2.5. So what should happen for us here is that if we've divided by 10 twice, we should be able to divide by 10 twice in our product. One decimal place and one decimal place together equals 2 places. And 12.4 times 2.5, 1, 2, is actually just 31. 2 decimal places. So you don't need to write down this section that I have in yellow over here. This is just something that we had thought about because we want to keep in mind that it is related to 124 times 25. It's just off by 2 factors of 10. So go ahead and pause the video. There are 2 slides of practice problems for this one. The first one's here I've set up for you vertically. Go ahead and pause the video now. Work on those 2 problems. Come back, we'll go through the answers, and then I'll give you the second set to work on. All right, well, for this particular problem with 3.14 times 28, let's start with the actual multiplication. 8 times 4 is 32. 8 times 1 is 8 plus 3 is 11. 8 times 3 is 24 plus 1 is 25. Have a 0. 2 times 4 is 8. 2 times 2 times 1 is 2, and 2 times 3 is 6. 2, 9, 7, 8. So 314 times 28 is 8,792. Now we have 2 decimal places here. We have 0 decimal places. in 28, add them together, that means we should have 2 total decimal places, 1, 2, 87.92. 87 and 92 hundredths. Now, if we look at the second one over on the right, we have 9 times 4 is 36. 9 times 1 is 9, plus 3 is 12. And now we don't have anything else to multiply together because there are no more non-zero digits. But we notice that we have 2 decimal places in 14 hundredths, 2 decimal places in 9 hundredths, and together that means we should have 4 total decimal places in our product. So if we start where we had at the decimal point here, we move 1, 2, 3, and then we need to move 1 more place, which means we need to add a 0 as a placeholder to write this product down. 4 decimal places, 126 10,000ths is our answer. So now, 2 last practice problems on the next page. I've not set them up vertically for you. You'll have to do that yourself. But see what you can do with both 25 times 25 10,000ths and 16 and 34 hundredths times 1 and 1,000. So if we look at 25 times 25 thousandths, let's set this up here in a way that's easy for us to look at. Of course, multiplication we can set up anyway, and I'm going to write it as 25 thousandths times 25 because I find that easier to look at than the shorter number on top and the larger number on bottom. So 5 times 5 is 25. 5 times 2 is 10 plus 2 is 12. Add a 0. 2 times 5 is 10. 2 times 2 is 4 plus 1 is 5. Add those together, we have 5, 2, 6. So 25 times 25, without any of the decimal places, is 625. And now we're looking at 4 decimal places plus 0 decimal places. It gives us a total of 4 decimal places. 1, 2, 3, 4. Again, add a 0, and we get 625 10,000ths. Finally, 16 and 34 hundredths times 1 and 1,000th. 1 times 4 is 4, 3, 6, 1, etc. because it's times 1. And now we have to be careful, and I intentionally set this up this way. We have one set of 0. We have 1 0 that we're going to add that 0 there for. Now everything is multiplied by 0, so now we're going to move on. We come to our second 0 in the tenths place where we'd have to add 2 zeros. And then finally, we've now come to our other 1, but before we start doing that, we have to add 3 zeros to the beginning there to represent that if there were no decimal points, this would actually be 1,000 rather than just 1. So then we continue on from there, 4, 3, 6, 1, etc. So adding these all up, keeping in mind where our columns are. So now, if we just had 1,634 times 1,001, we would have 1,635,634. Of course, we have decimal points here, so we need to know how many places to move them. 2 decimal places in 16 and 34 hundredths. 3 decimal places in 1 and 1,000 gives us a total of 5. So 1, 2, 3, 4, 5. And we have 16 and 35,634 hundredths. So as a brief matter of review, as the process for multiplying decimals, we ignore where the decimal points are as far as the setting up of the problem is concerned. We just have the rightmost digit or the smallest place values lined up as in something like 34 times 2 and 6 tenths, where the 4 and 6 are lined up, whereas in addition to the subtraction they wouldn't be. We go through the multiplication as if the decimal points weren't there, and we just use the number of decimal places that they have in the problem above, and that is the total number of decimal places for your product.